In this video, we will look at solving absolute value equations. There are three things to be aware of when you're solving an absolute value equal to a number, as we suggest here. And that is that number positive, zero, or negative? So one of the things I'm going to start with is let's assume p is positive. And then even though I have x here, it could actually be any algebraic expression inside of the absolute value. Let's start with this simply. The solutions of the absolute value of x equal to a positive number are going to be those numbers that are on either side of 0 on a number line. So that means x could be p or x could be negative p. So notice that or, what you end up with when you solve an absolute value equation are two possible answers here. One for whether that value inside the absolute value started as a positive number or it started as a negative number. An example of that might be if we have the absolute value of x equals positive 3, which we had in the last example, then remember we saw that x could be positive 3 or x could be negative 3 because the absolute value of negative 3 is positive 3. So you see how you have got those two results. If instead the absolute value of x is equal to 0, there's only one way that could be. That would be if x is equal to 0. And then finally, if we have the absolute value of x equal to a negative number, that is not possible. Remember, the absolute value of x is going to be the positive distance from 0. So you can't be equal to a negative number if you're defining the absolute value of x as a positive distance. So there is no solution in that scenario. So let's use these ideas, these principles, to solve some absolute value equations. We'll start with a simple one. Part A, the absolute value of x is equal to 4. Remember, the absolute value of x is saying that this is the positive distance of 4 from 0 on a number line. We could be either direction from 0. We can be in the positive direction or in the negative direction. So we need to have two possible results. Either the x is equal to positive 4 or x is equal to negative 4. And if we do a quick check, the absolute value of 4 is 4, and the absolute value of negative 4 would really be 4. So we would have a solution set that includes two numbers. The solution set would have a negative 4 in it and a positive 4. So two possible solutions. Let's go on to part B. The absolute value of the expression x minus 3 is equal to 4. Well, this is similar to the last one, but we've got a more complicated expression in here. But the rules stay the same. The distance of this stuff inside the absolute value must be 4. That means you could be in the positive or the negative realm from 0. So either x minus 3 equals positive 4 if you go the positive direction, or x minus 3 equals negative 4 if you go the negative direction. Again, you get two possible equations, two possible, therefore, solutions. If we solve for x on the left, we get x is equal to 7. If we solve for it on the right, we get x is equal to negative 1. If we do a quick check here, if we do a check, this one I'll write in because it's a little trickier, is 7 minus 3 when you take the absolute value of that quantity equal to 4? It is indeed. The absolute value of 4 is 4. So that's going to check. Over here, negative 1, if we put a negative 1 in for x, is that a true statement? Yes, it is, because we get the absolute value of negative 4, and the absolute value of negative 4 is 4. So we get both of those solutions working out. So once again, we have two solutions in our solution set. The solution set is negative 1, 7. Two possible results. In our last example of the page, we have an input of 5x plus 7 inside of our absolute value. Now, this absolute value, according to the statement, is equal to negative 2. That's not possible. Remember, what this is saying is that our distance from 0 is -2. We can't have a distance that's not positive or 0. Remember, we defined it as a positive distance, and this is a negative number. So this is not possible as we define absolute values. So our answer to this problem right away would be no solution. Okay, there is no solution to an absolute value equal to a negative number. All right, so let's check the answers we got to those previous equations using Desmos. In other words, let's check them graphically. So if we were to check or solve an equation graphically, we would want to enter in both sides of the equations, graph them. So let's start with the first equation, part A. Y equals, I would want to use the absolute value. Remember, the abbreviation is ABS, parentheses x. So there's my absolute value of x graph. And then remember, we wanted to see where that was equal to 4, so y equals 4 would be our second graph. So we see the absolute value as the v, the green graph as your y equals 4 line, and we can see that we're crossing at an x value of 4 as well as an x value of -4. So we have two solutions there at -4 and 4. That checks what we got algebraically. Okay, great. Let's try this again with our second equation. So our second equation, the left side was y equals the absolute value. And I'm going to use parentheses here because I want to include x minus 3, all of that. So there's my new graph. Notice that's a little different than the absolute value of x because it's not centered at the origin anymore. Our second equation, or the right side of the equation, would be y equals 4. So there's 4. And if we go to look at the intersections of these two, my first intersection on the left is at -1, 4. So -1 is the solution to that equation. We saw that algebraically. And I have another intersection at 7, 4. So those are the two intersections. And so I'm able to check that my solutions are -1 and 7, just like we saw algebraically. All right, let's check that last one that had no solution and see what that looks like graphically. All right, the left side of the equation would be y equals the absolute value of 5x plus 7. All right, so there's that black graph. That is the absolute value of 5x plus 7. I then want to also graph y equals -2. And when you look at where that line is, that horizontal line at y equals -2, it never intersects the black line. It is never going to intersect that. I can zoom out and you can see that horizontal line is totally below the v. And so therefore there is no solution because they're not intersecting. And we saw that, again, not algebraically, but through the meaning of the idea that the absolute value of something has to be a positive distance. So we can't have an absolute value equal to a negative number. So in that third equation, we had no solution.